channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're going to start discussing about the physics, which is of class 11th here, and that is your part 1, which is of class 50th, that we have to cover up here. On the same way, behalf of it, that what we'll discuss in the detail. This is your class unit 6, which is your work, energy and power. That is very important one. This is unit 6. We have to continue. We had started with the last topic we had done is your notions of work and kinetic energy, the work energy theorem that we had covered up with the numerical as well. So if you had not visited, you can go ahead, you will figure it out that as well. Now we continue with the next topic, that is your work. So let's go for the same. So in terms of work here, that is as seen as earlier, that the work is related to a force and the displacement over when which it acts, and you have to consider the force F that is acting on an object of mass n, and that the object undergoes a displacement of d in the positive x direction. So where that we have this is the distance here. So for that here this is the distance is d, and that is your x. An object that undergoes a displacement under the influence of the force F here. So here, as seen earlier, forces is related to the force and the displacement over which it acts, and you have to consider the constant force F that is acting on an object of mass, and that the object undergoes the displacement d, the positive x direction. Now here, that the work done by the force is defined to the product of component of the force in the direction of the displacement and the magnitude of this displacement. Thus work done by the force is defined to be the product of component of the force in the direction of the displacement and the magnitude of the displacement. Thus F cos theta d F d. We see that if there is no displacement, there is no work done, even if the force is large. Thus, when you push hard against a right brick, rigid brick wall, and that the force you exert on the wall does not work, no work, and that yet your muscles are alternatively contracting and relaxing to the internal energy is being used, and you do get tired. Thus, the meaning of the work in physics is different from its usage in everyday language. सो बेसिकली अगर एक नॉर्मल एग्जांपल लें तो अगर आप दीवार पे धक्का लगा रहे हो और दीवार चाहे दिन भर आप धक्का लगा रहे हो बट ऑफ कोर्स वो मूव नहीं करेगी, तो बट आप थक जाओगे धक्का लगाते लगाते, आपके मसल्स पे स्ट्रेस आएगा, आप टायर्ड हो जाओगे. सो ऑन द सेम वे आप तो थक गए बट एक्चुअली वो दीवार नहीं मूव हुई, तब वो आपका कोई वर्क नहीं होगा. सो here no work is done if one displacement is zero. Let's see the example below. A weightlifter holding a 150 kg mass steadily on his shoulder for 30 seconds does no work on the load during the time where the force is zero, and where a block moving on a smooth horizontal table is not acted upon by the horizontal force since there is no friction but may undergo a large displacement. The third is that the above the force and the displacements are mutually perpendicular. This is so since for theta equals to pi by 2 radian, that is equals to 90 degree, and cos pi by 2 is 0. For that, the block moving on in a smooth horizontal table, the gravitational force mg does no work, and since it acts at right angle to the displacement, if you assume that the moon's orbit around the earth is perfectly circular, then the earth's gravitational force does no work. The moon's instantaneous displacement is tangential while the earth force is radially inward, and theta equals to pi by 2. Let's go for the same. If no work is done, the displacement is zero as seen in the example above, where a weightlifter holding 150 kg mass steadily on his shoulder for 30 seconds and does no work on the load during this time. कोई भी वर्क नहीं होगा. जैसे कोई मान लीजिए कोई एक वेट लिफ्टर है जो वेट उठाता है, अगर वो 150 किलो का भी अपने शोल्डर पे, कंधों पे 30 सेकेंड या उससे ज़्यादा का भी उठाए रहे, और अगर वो वर्क मूव नहीं हो रहा है, डिस्प्लेसमेंट नहीं हो रहा है, सो इट इज़ नॉट comes under the work. So the second is the force is zero. Force zero कब होता है? A block moving on a smooth horizontal table is not acted upon by the horizontal force since there is no friction but may undergo a large displacement. उसमें कोई फ्रिक्शन नहीं है, वो स्लाइडिंग से निकल रहा है. मान लो एक ब्लॉक है जो बहुत भारी है, हमने इसको एक हॉरिजॉन्टल टेबल पे रख दिया है, एंड उस पर कोई भी फोर्स लग रहा है डाउनवर्ड टेबल पे, मगर एक्चुअली हम उस पर कुछ अप्लाई नहीं कर रहे हैं, एंड दैट इज़ नॉट एक्टेड एज अपॉन द हॉरिजॉन्टल फोर्स, सो देयर इज़ नो फ्रिक्शन. उसमें कोई फ्रिक्शन नहीं है एंड मे अंडरगो अ लार्ज डिस्प्लेसमेंट. अगर मान लो हमने यूँ रखा हुआ है तिरछे पे, तो ऑब्वियसली अगर वो अपने आप मूव कर रहा है, फ्रिक्शन नहीं है, वो अपने आप मूव कर जाएगा, तब भी हम उसमें फोर्स को ज़ीरो कहेंगे. द थर्ड केस इज the force and displacement are mutually perpendicular. This is so since for theta equals to pi by 2 radian equals to 90 degree and cos pi by 2 is equals to 0. So for the block that moving on a smooth horizontal table, the gravitational force mg does no work, and since it acts as right angle to the displacement, and if we assume that the moon's orbit around the earth is perfectly circular, then the earth's gravitational force does no work and the moon's instantaneous displacement is tangentially, while the earth force is radially inward and theta pi by 2. So work can be both positive and negative. If theta is between 0 to 90 degree, cos theta in, and that is positive. If theta between 90 and 180, the cos theta is negative. And in many examples, the frictional force opposes displacement and theta equals to 180, then the work done by friction is negative. Okay, so let's go for it. What can be both? Positive and negative. If theta between, just I write it down. 0 degree and 90 degree, cos theta is positive. Theta is between 90 degree and 180 degree, cos theta is negative. And if many examples, the frictional force opposes displacement and theta equals to 180, then the work done by the friction is negative, which is cos theta minus 1, that is cos 180 minus 1. So here that it is clear that the work and energy have the same dimensions, ml square t inverse square. The SI unit of these is joule, and named after the famous British physicist James Prescott Joule, which is 1811-1869. Since work and energy are so widely used as physical concept, alternatively units abound, and some of these are listed. We'll discuss with the table. Alternative units of work. So that is urge. Electron volt. Calorie. Kilowatt hour. is 10 to the power minus 7 joule. 1.6 into 10 to the power minus 19 joule. 4.186 joule. And 3.6 into 10 to the power 8 joule. Okay, that is comes under kilowatt joule here. It is 10 to the power 6. Now we discuss with a question here, that the question we have, where a cyclist come to a skidding stop in 10 meter. During this process, the force on the cycle due to the road is 200 Newton and is directly opposed to the motion. How much work does the road do on the cycle? The second is, how much work does the cycle do on the road? That is the other questions. Let's go and figure it out. So we do that in the next coming class. So here we're going to end up with. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.